This is Unpacking K-5 Math for Caregivers, and we are going to talk a little about what does it mean to implement the division algorithm and how to think about division. So, Temple.
All right. So what we're going to do here is we'll have obviously conversation like we always do, but I thought we would start with having caregivers think about the way they might solve a multi-digit division problem, and then we can talk a little bit about the ways that we might see kids doing it and why we might see it that way. And then I do have some slides here that I'll share that really shows kind of what's happening when we do that traditional algorithm, because I think that we often use language that doesn't attend to the place value, and so you don't really understand exactly what's happening in terms of the decomposing and recomposing numbers. So so the problem, let me share my screen. So the problem that I'd like for you to think about is, let me get down here, is 548 divided by 4. And so if you want to jot it down, pause this video, jot that down, and maybe think about and write down the way that you would solve it based upon the way that you learned when you were in elementary school. So I suspect that many of you, and perhaps not all, because there are multiple ways to do this problem, but in terms of in the United States, I suspect that many of you probably set it up this way, and that your work may have looked something like this, where you found that the quotient is 137. And, you know, a lot of times we might hear the language like, does 4 go into 5? Yeah, 4 goes into 5 one time. 1 times 4 is 4, and we subtract and we bring down the 4. And so what we want to do in this video or video cast is to talk about how that language doesn't really attend to thinking about the place value of the digits in that number. And then also the fact that the approach that this approach, which is more the traditional United States algorithm, according to our standards, students actually are not expected to learn this until 6th grade, and instead they're supposed to develop other strategies first. So I think as a caregiver, you might see like your 4th or 5th grader doing some work with division and wonder, why are they doing it that way? And the reason that they're doing it that way is that they develop the ideas of really what's happening when they're dividing before they try to develop something more efficient like this traditional algorithm that you learned when you were in school. So with that, and so let me say a couple of more things, and then I'll pause because I want Valerie and Paola to be able to talk as well. With that, when we think about, a lot of times we talk about fluency. And so I think that, you know, how fluent is a child with their algorithms, with the operations. And so Susan Jo Russell talks about these 3 components. And I think as you know, as a caregiver, we might think that fluency means that they're super quick. Efficiency is one piece of fluency, but I think that last bullet there, flexibility, is perhaps the most important. We, of course, want accuracy as well, but to be flexible in the ways that we think about numbers. So that's what teachers in elementary schools are doing. They're trying to help students support them in their flexibility with number and the using different strategies, again, that make sense of the algorithm that they're using. And so, and then, I mean, I'm not going to talk about this slide a lot, but Susan Jo Russell also talks about that this fluency does rest on this 3-part foundation. And I put there in red font, I think the core of what we're talking about here today is that they have a really solid understanding of the base 10 system and knowing how it works for different operations. That's going to support their fluency in the sense that they're, of course, accurate and efficient, but more so flexible in the way that they think about the operations. Okay, so that being said, I'm gonna stop sharing my screen, and I want to talk. Instead I want to talk about 548. I still want to talk about that problem, and I want Paola and Valerie and I to talk about the ways that we might solve it a little differently using a partial quotients approach, which is an approach that you probably see your students using, and so. The reason I want to do that before talking about the traditional algorithm is because I think it's important that we talk about again, the ways that you see your children doing it. So, Paola and Valerie, did you think about 548 divided by 4?
Yes.
Oh, you want it, Paola?
Okay.
You all see what I'm writing here?
Yeah,
Can you see it?
I can see it.
I can pull my laptop a little closer.
Yeah, that's better. But are you saying, so are you talking about mental math, how I did it in my head?
Well, I'm actually talking about like the fact that I think about that I can. You want me to share my the way that I thought about it first, and then maybe I'll help the way you have the two of you share. Is that cool? So I actually thought about, okay, I know that I can get 100 groups of 4. Because I'm trying to figure out like how I can think about this in 2 ways, right? I can think about 548, putting that number into 4 groups and figuring out how many is in each group, or I can think about how many groups of 4 I can make out of 548.
Mm-hmm.
So I thought about I can make, okay, 100 groups of 4 definitely fits. So 100 groups of 4 is 400. And then that leaves me with 148. Can you all see that?
Yeah.
So then I'm thinking about, okay, how many groups of 4 can I make at 148? So the next thing that I thought about is I know that I think about quarters, and I know that 25 groups of 4 is going to give me 100, and then I'm left with 48. And now I'm thinking about, ooh, my glare there. How many groups of 4 could I make out of 48? Oh, I can make 12 groups of 4. Now I'm finished. And so I made 100 groups of 4, 25 groups of 4, and 12 groups of 4. So all I have to do is add these together, and I have 100. Oh, that's the same quotient I got using the traditional algorithm. I can make 137 groups of 4, but these were my partial quotients, 100, 25, and 12. And so I'm wondering, this is the reason I'm bringing attention to this particular strategy is because it's very common. Like I expect I have a 4th grader that lives here in my house, and she's been using this strategy in her 4th grade just recently. She's been doing division, and this is what her teachers have been doing with her. So I think about caregivers who have a 4th or 5th grade student. They're probably going to see their 4th or 5th grader doing something like this. Now they might stack these quotients up on top, but they might do something like this in terms of an algorithm that they use. So I'm wondering, if either of you thought about it differently in terms of, especially like these partial quotients that are result, so that we can just show caregivers how it doesn't always look the exact same way. The way I do it might be different than the way that the two of you do it. So maybe I should erase what I have here. That sound good? And if you want to say anything else, please do.
Mine is very similar, Temple, but the difference is I started with 500, so I can make 125 groups. I can make 125 groups, and that will give me the 500. And then I had the 48.
So then,
so instead of breaking the 500, 125 groups of 4.
125 groups of 4?
Yeah.
Okay. 125 groups of 4
gives me 500.
It's 500, and then you're left with those 48 to figure out how many groups of 4.
Right, and then I have 12 more groups of 4.
And then you did 12 more groups. So just what the point here is, notice that I did 125 and 12. Paola was more efficient. She did 125 and 12, but that's okay. Like I did what was friendly for me, and you did what was friendly for you. And that's the nice thing about this. This is an algorithm. That's the nice thing about this algorithm, is that it allows a kid to use, or an adult, to use what is friendly for them in terms of the way that they think about the number.
Mm-hmm.
So then, Valerie, what about you?
Yeah, so one thing I do want to point out is, having a background in special education, is that the working memory issues are really interesting here, right? So holding on to these algorithms can be quite hard for kids. But if every step of the way I understand what I'm doing, like Paola clearly understood 500, well, I know there's 125 and 4s and 500. If every step of the way is clearly understood, it actually reduces working memory, even though to parents, it probably looks like a lot of steps, but they're all clearly understood steps. Now that's different than memorizing something that's kind of sitting up in a different part of your brain that's just like something I have to do, right? So for me, I tend to make the simplest possible steps for myself. So I started with 400. So, and I didn't really picture the standard algorithm. I just said to myself, well, I know right? 400. Okay, I know I'm going to get 100 fours and 400. And now I got another 100 I have to deal with. So I'm going to get 25 out of that one. And now I've got 48. So I'm going to make this as simple as I can. I'm thinking of it as 40. And I'm going to get 10 fours and 40. And then I've got an 8 left, and I have 2 4s and 8. And every step of the way, I was feeling like I'm totally solid. I know exactly what I'm doing. All I have to do is kind of write these partial quotients down. And I actually was able to hold them in my head. And honestly, I did not put them together in my head. So now I'm seeing, right, 125, 135, 137.
Yeah. But see, so your partial questions were similar but slightly different, right? I mean, I think what you've raised here is really important in terms of thinking about. To me, like, this just allows kids to do what's friendly for them, and really, so that, yeah, again, in terms of what they are having to hold in their brain. And I know that, like, even with my undergraduate students at NC State, sometimes when I'll ask them about, like, especially if they've had like a turning point in terms of when they maybe started to develop some more negative attitudes about math, sometimes it's long division that has created that for them, because they were forced to try to memorize some algorithm that didn't make sense to them. Whereas, like, I feel like, again, it's what makes sense to the individual child. And I know that when I taught 6th grade, they came to me actually where a teacher had done this with them, and they were pretty successful with dividing it. And sometimes I would see long strings of numbers over here on the side, but it made sense to them. And then through some talking, you'd see them become more efficient and have less partial quotients. But it's a really important point, Valerie, that you make around that. As a parent, you might think, oh my gosh, that looks like so much work. But it's actually pretty efficient for them, right?
It
upon what, yeah.
And when we define efficiency, I think it's it's short-sighted to think of efficiency strictly in terms of how much we put on pencil and paper.
Right.
It's efficient to learn things that you can actually do in a grocery store, right? It's not that efficient to pull out a piece of paper and do long division at a grocery store. But if you understand it, you've actually created a more efficient long-term strategy that can be used anywhere.
Right. Which is what I heard both of you do, really, right? Like, you were chunking this number, and this promotes being able to do it mentally.
Right.
So that at the grocery store, you're not pulling out your phone to use your calculator or a piece of paper. Yeah.
And that's what I was going to say. I understand and appreciate the power of the algorithm and learning it. But honestly, I, as a learner, could never understand division. You know, I would do it. I memorized it. I was good at it, but it made no sense to me. So as an adult, I either do a mental math way that makes sense to me, or I'll go to my calculator. There's never a time where I feel like, oh yeah, I can just do that, because to this day, I have to think about that algorithm and I get confused. And honestly, we show it differently than in the US way. So then if I am even trying to show to someone here how they do it, but I didn't learn it that way, and it is so memorized that I can't apply it somewhere else. I have to think every time. So I can do partial quotients, and that's what I do most of the time very quickly. It's meaningful. I can do it anywhere. And as an adult, if I can't do that, honestly, I'll pick up my calculator. There is not a single time that I feel like, oh, let me just write this down really quickly as a traditional algorithm. So I'm not saying kids shouldn't learn the algorithm, because it might make sense to them. but I would even argue that the partial quotient ones, you could be quicker at that than at the more traditional. If you get stuck every single time in the traditional, to this day, I have to think, oh, which number comes down now? Or when it goes into decimals, I'm like, wait, where does the decimal point go? You know, is it now that I can add a 0 again? And when can I stop doing that? So even if you're worried about accuracy and efficiency, this might be more efficient and accurate than the traditional algorithm for many kids. Plus, you have the bonus of the flexibility with the understanding numbers. And back to what, every time we seem to go back to this idea of, you know, being able to decompose your numbers in useful ways.
Yeah, my sister who's here just mentioned it's less stressful. And so it's less stressful if the teacher can work with you to find a way that is really comprehensible to you, right? And that's not a minor detail. Anxiety and working memory are stored in the same place in the brain. So when anxiety goes up, working memory goes down. So if we can find a happy place where kids aren't as stressed, their working memory actually is bolstered, or at least not reduced. And so that is important. It's not just a matter of like sticking in there and sticking with it, kid. This is one of those places where you want to loosen the student up so that they can be sense making while they're doing the whatever algorithm they're using in their head or on paper.
So, yeah, I was going to move us to words for caregivers, but go ahead, Temple, and then we can.
Can I share one more thing before we do that real quickly? So I do want to show, because I have these slides, I do want to show real quickly this traditional algorithm. So with using some blocks here, so that's 500, 4 10s and 8 1s, 548, and I'm dividing it up by 4. So I thought about this, if I'm making sense of what perhaps the way you did it on paper, that I'm putting this into 4 groups. So there's my 4 groups, and I'm going to put 548 in. And so you can see I start out with that. On the left there, you can see what's happening with the traditional algorithm. But I first put 100 in each group, and I'm left with that leftover 1 over here. Actually, let me use my cursor. That leftover 1.
100.
Yeah, 100. Thank you, Paola. That leftover 100 is hanging over here. And so then, but really, so this notion of bringing down a 4, I really have 104 10s, which is hanging out over here, right? But really, it's 14 10s that I'm now going to divide up and put into these 4 groups. And so I can put 3 10s in each of those groups. And so now I have 2 10s left over here on the right. And we bring down that 8. Well, those are just those 8 1s, right? So, but really, I have 2 10s and 8 1s, but really that's 28 1s.
Right.
So I've decomposed those 2 10s and 28 1s. Now I put those into groups, and there you can see that I put 7 1s into each group. So I lined it up there just to show. So I have 137 in each of these 4 groups. And the reason I wanted to show you that is just to, and I think that's the last slide, just to show what's happening with that traditional algorithm that you do, that you probably do at the caregiver.
That's very cool.
Yeah, and I know that we need to wrap up, Paola.
Oh, that's okay. Well, if I were to wrap up, I think what I would say to caregivers is actually try yourself. If you haven't used this algorithm for this way of thinking that we were proposing, break the number in different ways to solve a division problem, try it yourself a little bit, get comfortable with it, especially if you've never seen it. And then I believe it is for me, it was so insightful that when I realized I could do it this way, and I think you might like it. And then you can engage in conversations with your child if you're thinking about numbers in different ways as you're breaking them to solve a division problem, which would be very productive conversations to have.
Yeah, and depending on comfort level, there's some parents who really like the standard algorithm. They're comfortable with that. Then I would say that the first step would be to do as Temple is suggesting, that use the correct language for what each digit represents. So don't call a 1 a 1 when it means 100. So as you're going through that algorithm, can you connect those digits within the numerals to their actual meaning as you're talking? And I think that would help somebody like Paola. You said it was a stressful algorithm for you. I know it was, you know, my sister's sitting here, and I know it was for her because I helped her with it.
It is.
Yeah. But if you're saying, okay, I've got 548 okay, so first question I'm asking you is how many 4s are in 500? Okay. You know, and so you're just keeping track of what's actually happening, as opposed to turning everything down into, well, you know, 1s, when that's not really what's happening. So that would be a first step, is to really try to do that connection like Temple showed in those last few slides, in terms of the language you're using as you're talking it through.
And I think for me, the other thing my other tip would be, if you see that your child is having success with this algorithm that we use, which was a partial quotients approach, let them do it, you know, and like let them be, even though it may, as Valerie mentioned earlier, from your perspective, it may look very inefficient and like, oh my goodness, why are you doing it that way? Let them do it, right? And just let them do it that way because it makes sense to them. So that would be my advice.